When you think of space, you think of just that, space, emptiness, the void. But when it comes to the space around Earth, it's actually not that empty. It's filled with a whole bunch of junk, or space trash. In fact, experts think that there are millions of pieces of debris in orbit, ranging in size from bigger than a softball to smaller than a marble. So what is all of this junk hanging out around our planet? Well, that's the awkward part. Just like trash here on Earth, debris in space can be a big problem. It makes the space around our planet a congested and potentially dangerous place. You may think space debris is just floating out there all slow-like, but this stuff isn't really floating at all. It's actually zooming around Earth at more than 17,000 miles per hour.
Our activities in space have left traces behind, and certain orbits are at risk of becoming congested. About 17,000 man-made objects are currently being regularly monitored from the ground. Some 10,000 of these objects are fragments created by more than 250 explosions and collisions that have occurred in orbit. Explosions are caused by energy reservoirs that remain unused upon completion of a mission. Only 7% of the monitored objects are functioning satellites. The effect has been particularly evident in the low Earth orbit region. This extends to a height of about 2,000 kilometers. Two-thirds of all known artificial objects can be found in this comparatively small region.
Until 2007, experts tracked around 12,000 large pieces of junk. But since then, two events have caused the situation to degenerate. One involved Cosmos 2251, a Russian satellite in low Earth orbit that suddenly malfunctioned. The Russians could no longer communicate with it and were unable to deorbit it to Earth. In a perpendicular trajectory at the same altitude, a brand new American satellite called Iridium 33 was in orbit. The impact sent debris flying in all directions. Around 1,000 pieces larger than 3 inches and thousands of smaller fragments were ejected into space, posing a threat to all the devices in low Earth orbit. This collision proves that an out-of-control object in low orbit is a danger to all working satellites. Another event worthy of Star Wars took place when China decided to deliberately destroy a weather satellite that was no longer in use, using a ballistic missile armed with an infrared seeker and a warhead. It was an arrogant show of strength by Chinese authorities, with no concern for the consequences. As a result of these two events, by 2010 there were more than 17,000 large pieces of debris circling the Earth.
So at the moment, if you are a satellite operator, every once in a while you will get an email from the U.S. military or from your government that says 3 or 4 days from now, your satellite is predicted to have a close approach to another space object. The probability of collision is 1 in 10,000, 1 in 1,000, 1 in 500. Good luck.
A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean.
It is not comparable to a gunshot. The energy contained in a 1 centimeter particle hitting a satellite at that velocity roughly corresponds to an exploding grenade. So the consequences of such a hit mean a satellite failure, For larger objects, even satellite destruction and fragment generation, which again then has environmental consequences.
What space debris experts fear most is a chain reaction, where objects break apart in collisions and fragments go on to smash into other objects, creating more debris.
These collisions generate more fragments, and these fragments are candidates for new collisions to come. So follow-on collisions, if you like. And that the largest fear that we have is that we enter in some sort of cascading effect, where one collision triggers the next one. And this is not anything that will happen within a microsecond like in the movie Gravity, but this is something that will set in slowly, hardly noticeable, but unstoppable.
Even if no more launches took place and the space debris situation was left to its own devices, simulations have shown that the number of objects will not decrease but increase. This is caused by cascading collisions between resident objects and fragments of prior collisions. That scenario indicates that the critical density of objects in the low Earth orbits has already been exceeded. The more objects accumulate in orbit due to spaceflight activities, the more frequently such collisions are going to occur. In future, more and more collisions with fragments from earlier incidents are going to occur. This collisional cascading effect was already predicted some 40 years ago. The exponential increase in the number of objects is extremely difficult to slow down. If the current number of launches continues and no countermeasures are taken, the collision rate will eventually be 25 times what it is at present. This would make spaceflight in the important low Earth orbits almost impossible. Active intervention is the only way to reduce the present critical density to a sustainable level. The active removal of large and uncontrollable objects is a considerable technical challenge associated with high development costs.
The problem of the space debris has to be fixed in two ways. First one, we need to stop polluting. And second way, we have to remove the garbage, if you want, and the debris.
At ESA's ESTEC Centre in the Netherlands, engineers are developing eDorbit, designed to capture an out-of-control satellite and remove it from harm's way. It's being tested using a robot and satellite model.
We use the camera, which is mounted on the smaller robot arm, to reproduce the motion of the satellite around the target satellite that we want to deorbit, to capture. Once we are sure we are moving like a single object, we are like, as if we were dancing, but without touching it, each other, we can move the robotic arms to grab the launcher adapter ring. So it makes us easy to bring it down to the Earth and destroy it in the re-entry or in the South Pacific Ocean.
Another approach involves using nets to capture space junk.
So the concept is to, let's say, to mimic what the fishermen do on the sea, and so to have a very large net to stay away from our debris and med satellites that is tumbling and moving freely, and then from that distance to keep our net, and you just try to wrap all over your satellites.
There are a few countries, Japan, the United Kingdom, the European Union, that have started to put money into removing some space debris, but it's very early stage. And these are essentially demonstration missions to go remove one or two relatively small pieces of debris to prove the technology. But this is going to cost them quite a bit of money, and for the moment, none of them really want to spend that money.
Now imagine sitting at home and you hear a loud boom. Then you discover something had crashed into your roof, blew through the floor, finally lodging into your bedroom wall. Well, it just happened to one homeowner, and as Stephen Fabian reports, the flying object came from outer space.
A mysterious object falls from the sky. You can hear the impact when it crashes into a home. Look at the damage it caused. A hole from the roof straight through the floor.
It's either space junk or space meteorite. It's 50-50.
So what was it? Turns out it was space junk from the International Space Station.